Hello everybody, welcome back to our linear algebra course. Alrighty, so in previous lectures we have been talking about a lot about the determinant. So from today's lecture we're gonna move on to our. Alrighty, so what is matrix? Here's one simple example, this 3 by 3 determinant. So in the form, right from the observation, we simply just take out these two vertical lines, which is the sign of determinant, but replace them with the brackets here. So then we can call it a matrix. That's easy, right? From your observation visually. Okay, so what is the fundamental difference? Well, remember, for determinant, no matter how complex it looks, however, in the end, you will get a value. For example, we will say the value of this determinant is A. So it's nothing but just a number, a value. However, if you replace, those two vertical lines with these brackets, we're focusing on the elements, elements instead of the matrix. We're going to talk aloud about the properties and operations about those elements. So to make this sound more natural, so remember, we actually have been mentioning frequently about the concept of matrix when we were discussing the determinant. We're saying that, well, actually, for each column in the determinant is nothing but the column vector in the n-dimensional space. So here, in a matrix, when we're going to talk about the properties and operations of matrix, actually we're focusing on the operations and properties of the column vectors. Yeah. So basically, for determinant, we only care about the final value, determinant's value, which is a number. But for the matrix, we're going to talk about more, behaviors of these column vectors. Okay. Alrighty. So in this part too, about the matrix, we're going to talk about the definition and operation of it. So as you can see that linear algebra is one of the subjects defined artificially by the ancestors, of course, because we need them, right, when we're resolving the function groups. Yeah. So, but in the future, especially for the students from the physics or the mathematics majors, you probably will have to learn a lot about the artificially defined algebra later, which is, of course, together with the linear algebra as a part of the advanced algebra, which is part of the advanced mathematics. So, which is a sister of the calculus. So, since it is just artificially designed algebra, right? I mean, if you master the ideas of the linear algebra, what to say the idea of the advanced algebra, you can make your own algebra subject too later if you want to make your calculation or make your profession, calculation easier or look more convenient for you. So as we have been learning algebra since the elementary school, we understand that in the algebra we have to talk about the operations, right? So operations always include addition, subtraction, and multiplication, right? So later if you want to make your own, for example, super algebra, your choice, you can also, put the definition of the basic operations such as addition, subtraction, and multiplication in your own words, okay? So we're going to talk about them one by one. So now, some students may be curious to know, yes, since you have the multiplication, we understand that addition and subtraction are like sisters. They are always in a pair. So there should always, be the division, right? Yes, of course. There should be division, which is the reversed operation of multiplication. Okay. However, in the linear algebra, the division is so special. So we will call it, the reversed, this, to find the reversal of A matrix, okay? All right, so in order for us to find out A, A's, reversed A, we'll have to talk about a lot like the invertible matrix, which means just like our basic algebra. So for example, if we just talked about the rational numbers, okay? Only the rational numbers, you can say that you have numerous choice for the numbers which can be divided. However, and only accept one number, which is 0. So you cannot say that you can do some operation like this. So first of all, we have to make sure that we can do the division operation on this matrix. So we have to talk about invertible matrix, and then we have to talk about adjoint matrix, which is like the preparation knowledge to find out the this reversed matrix. Okay, so and then we will extend our concept to the elementary matrix, and then talking about the matrix function. This is very natural, because remember, when you are learning the algebra, first of all, you're learning the basic operations: addition, subtraction, multiplication, division, right? And then your teacher will ask you to, can you find out some unknown variables value? Then you begin to form the concept of equations, such as x plus 2 equals to 5. So what is x? And then you have expanded your knowledge to the second order, third order, and then to to the multivariable equation x plus y equals to 6. Yeah. So we're just we have been deepen our math knowledge step by step. So similarly, so if we have all this knowledge prepared, like the invertible matrix, adjoint matrix, elementary matrix, done, so we will get ready to resolve our matrix function. So in this time, the unknown variable we want to find is not a single number, but a matrix. Well, that sounds cool, right? All right, so let's continue. Alrighty, let's start with, if you have been learning with me for a long time, you understand that, yes, from the we always definition. Have to start from the definition. Okay, so that's like the fundament for whole tall building. You have to make sure that you have the clear definition, and then you can build up. So for the matrix, from our simple example, we just have to take out the two vertical lines and replace them with the brackets. And we say that, well, other, concepts are very similar. So matrix are also composed with those column vectors, right? So here, we give it a very clear definition based on the column vectors. So it is, the matrix is composed with, I would say n, which is the number of the vectors. So we have n vectors, and for each vector we'll call it the m dimensional vector. So with m dimensional vectors. Okay, so we have, for example, we have the first one as alpha. Okay, I will put it here to make it more clear. So for the first one, alpha 1, that's the first column vector. So basically we can say, we have a1, 1 as the vector, a2, 1, and blah, blah, blah. We have n, m, 1. Okay, so you can see that, yeah, you can see that we do have the m-dimensional vector. So similarly, you can write the similar, alpha 2 vector, alpha 3 vector, and all the way to alpha n vector. So for alpha n vector, we just have to change, the subscript as a1n, a2n, and all the way to amn. Okay, so the first subscript means the indicator of the row and also the dimension of the column vector. And the second subscript script means the the indicator of the column, or say the which column vector you're talking about. Okay, they are all equivalent. All right, so any matrix. Oh, there's something wrong here. So be a matrix. Okay, it's composed by the column vectors like this, and all together we just wrap those vectors right together, and we're gonna have, and we just put a notation as A, okay, as a matrix. So with n m-dimensional column vectors. Okay, so let's put everybody together. So we have A11, A21, all the way to AM1. M1. And for each row, we have, all the way to n subscript, 2n, okay. And this one is mn, okay. So you have to practice this definition by yourself on a piece of paper with your pen, please. Yeah, the handwriting is so important for you to remember and for you to understand. Okay, so we say that m and n are not necessarily the same. However, when m equals to n, we will say that this is the, we call it, the matrix as nth order matrix. Okay, so this is the general form of a matrix, and this is the special form of a matrix, the nth order matrix. The nth order matrix is the core matrix we're going to talk about. All right? Alrighty? So we just defined our matrix clearly. So now, what is next step? Yes, as we mentioned, after we have the definition, we'll have to talk about the operations of the matrix, just like what we did in elementary school. So the first one must be the, addition operation. Alrighty, so addition operation will probably not appear on your test paper because it's too simple. So here, I would say, we have a matrix A plus a matrix B. So this time, you just have to let the corresponding element to be added together. So which means I would just use the element notation here. So for A, with the subscript Aij plus the Bij. B is the element from the matrix B. So you can see that our subscript are exactly the same. Okay, so finally, we will still have, this m times n matrix. So you just have to let each element plus, added together. But remember the corresponding. You cannot have, A12 plus B13. This is wrong. You have to, let A12 plus B12, the corresponding element in each matrix. Unfortunately, this is not a, testing point on your test paper in most universities, but maybe on your quiz, you can still see such problems. Okay, so the next one is a little harder, but still very simple, relatively, compared to the later operations we're going to talk about. It's called a scalar operation. I'm sorry, scalar multiplication. Okay, scalar multiplication. So it's about a multiplication, which sounds harder than addition. But this one is actually, well, if you want to calculate it, it's actually easier. So this one is about a number k times the matrix A. So you don't have to do anything complex, but to let this, scalar number k times each element inside of this matrix. Okay. So you will still get a n times n matrix. So here we have assumption that for each matrix, like matrix A, it is the n times n matrix, just to make this matrix looks very general. Okay. So now if I give you a little question, can you think about it? So for example, A minus B. Oh, well, that's abstraction. How can we do this? Well, addition and subtraction are actually the sisters. So basically, we can just transfer this operation as A plus minus 1 times B. See? Now we have this as the scalar multiplication. So you can just multiply minus 1 to each element inside of the matrix B, and then let the matrix A and this minus B added together. Okay, not hard, right? Okay, so if you're ready, let's get on to something more complex. Yes, the next one will be about the real multiplication operation. Okay, so this one is the key point for the basic operations of matrix. Please pay attention. This one is very important. Okay, this one is very important. Okay, so for this one, if we have a matrix A, which is n times n. Okay, so we have m rows and n columns. So I would say times the matrix B with the m rows and n columns. Can we do it? Actually, this is now defined for the matrix multiplication. Well, maybe later in the future you can define some algebra which can, have a definition of such things. But in our current linear algebra, such multiplication has no definition. So it means not all matrices can be multiplied together. Okay, so we have to make sure that. Okay, so the subscript of the matrix B should be looks like n times s. Means for matrix B there are n rows and s columns. Okay, so you find out, yes, we have to make sure that the column number of the matrix A has to be equal to the row number of matrix B. And this time we have the definition for such multiplication. Alrighty, so this one, you will say, oh, so what is the, the matrix, of the product of A and B look like after that? I would say, yeah, we'll call it a new matrix C, right, A, B, C. So the new matrix will have m rows and s columns. Yes, you find out that right. So we just put a row number here and a column number here. Okay, so for each element in C, we call it the lowercase c, I, j, in this m times s matrix. All right, so after this very brief notation, I want to write something key words for you guys. So the first one to keep in mind is, the column number of A. Column number of A has to be equal to the row number of B. Yeah, they're always to be equal. If not, sorry, you cannot do the multiplication. Okay, the second keyword is, so for each C element, how, we understand, what a C matrix product looks like. It has M rows and S columns, but how can we, calculate each element of Cij? Okay, this is very time consuming, and it is very easy for you to make a mistake. So, from the definition, I would say that, Cij, the element of C matrix, is actually the element, I will just use ELE to indicate the element of matrix A, well, in ith row. Okay? And then we will, have the element of column B to participate. So the element of B in jth column. Okay, so you can see that, I comes first. So it corresponding to the matrix A. And we have to find out, the element of matrix A in the ith row. And J, comes later. So we have to find out, the jth column in matrix B. And then we will do the inner product. So what is inner product? Well, if you happens, have no idea about the, vectors inner product, here's the little lesson here. So for example, we have a vector, I would say alpha, okay? So we have 1, 2 for alpha. And we have a beta as another vector as 3, 4. So the inner product is, we put a dot here, so alpha dot beta equals to, okay, you just let each element, corresponding element, to times together. So we have 1 times 3 equals 3, and 2 times 4 equals to 8, and then add them together. So finally you will have 11 as the inner product of the two vectors. Alrighty, so if you have no trouble with this inner products, let's continue. So here, we're going to have one example here. Okay, so I will write a arbitrary matrix for you, which is 3 times 4 type of matrix. Means we have 3 rows and 4 columns. Okay, so this is 3 times 4 type of matrix. And this time, we're going to let this matrix times a matrix which has 4 rows. And yeah, we have to make sure that it will have 4 rows. And it can have maybe 1 column, 2 columns, 3 columns, or 100 columns. Yeah, it doesn't matter. But we have to make sure that the A matrix's row number and the B matrix's column number are equal. So this time I will do this one as this. Okay, so this time it's a 4 by 3 matrix. Okay, so before you do your calculation, let's imagine what this product matrix will look like. So we see that the final product's subscripts will comes from the matrix A's first subscript and the matrix B's second subscript. So we have 3 by 3 matrix as the product of the matrix this one and this one. Alrighty, so maybe you can stop, pause the video for a minute and calculate. calculate it. And maybe you can use a stopwatch to see how many minutes did you spend on it. Alrighty, so if you have a little trouble to begin with, well, let's do it together, hand by hand. Okay, so we say that, the first element in this product has to come from, for this element, I would say this is C11 because it is in the first row and in the first column. So, for C11, the first subscript means, the first row from the matrix A, right? And, the second number, which is also 1, means the first column from the matrix B. So then you can do the inner product of these two vectors. So for this one, we have 2, times 1. Okay, this is 2, this is 1, right? Okay, and then we have 2 plus 1 times 2 and plus 5 times minus 1 and then plus 4 times 6. Okay, let's do it. 2 plus 2 plus minus 5 and plus 24. Alrighty, so this one seems to be, yes, you can use a calculator or you can just do it on your piece of paper. So we have it as, yes, 23. Yes, 23. So we can replace this one as 23. Okay? Alrighty, so let's try another column. So for this one, we have C12. So C12 means, yes, it is in the matrix C's first row and second column. And we understand that, the first indicator 1 comes from the matrix A's first column. And next, subscript 2 comes from the second column of matrix B. Okay? So this time, let's try. 2 times 5 plus 1 times minus 2, and then 5 times 3, and then 4 times 7. This time we have 10 minus 2, 15, 28. So this one's going to give us, yes, 51. Okay, so did you pause the video and calculate the other elements in the product matrix C? If you did, perfect. So let's double check if you got the correct answer. So we got the first one as 23, second one as 51, okay? Okay, I will move this a little bit here to make it more clear. Okay, and third one in the first row will be 47. Okay, next row will be 46, 23, 38, last row will be 33, 39, and 21. Did you get the correct answer? Well, if you did, probably you have mastered the calculation methods about the two matrices. Okay, so basically that's what we've been talking about today. So we have been talking about the definitions and the operations of the matrices. So if you got the time, it's really highly recommending for you to go over these definitions and very basic operations, especially to the multiplication of the two available workable matrices. Okay, so please do some practices, and I will see you next time.